Good morning, everybody, or evening. Well, we're going to talk about how to quantify energy, basically give energy a number. And we're only going to talk about two types of energy right now. We're going to talk about kinetic energy, and we're going to talk about gravitational energy. So, really important that you take notes. These will be worth points. And the second thing is, when we get to class Monday, we will have a little quiz. So make sure you are ready. Here we go. First one is gravitational potential energy. It's very important that we think of it as gravitational. So here's our equation for it. Potential energy is mass times gravity times the height. The height that it's going to fall through, the height that it is above something. So in this problem we're going to do, we see that the waterfall is 35 meters tall and a log is at the top, and that's its mass. So we would just say its potential energy is its mass times gravity times how high it is. Riveting, I know. Oh yes, I know. 700. Kinetic energy, so 1/2 mv squared. It's very important. Two things that students always forget is that this is squared. Next thing is only the v is squared. That is something that keeps coming up. Kinetic energy, it's when something's moving. That's the indicator that I have the energy. And if you look here, I have a velocity. If we go back to potential energy, what did we have to have? Our indicator of gravitational potential energy is it has a height off the ground. Alright, so my daughter, Mackenzie, has a mass of 15. She's running at 3.2. How much kinetic energy does she have? Lay out your equation every single time. Kinetic energy is 1/2 mv squared. So it's 1/2 of her mass. Her velocity is 3.2. Square it, and you're going to get whatever this says right here. So now my calculator. 76.8. Here's 3 problems for you. Do them right now. Pause the screencast, and when you're done with them, I'm going to go through them and show you the answers to each of them. That way you know you're doing it right. But Monday, I expect to see these 3 problems, and we'll have one just like it. So jump in right now, do those, and then hit play again when you're done. So this last one, sometimes people get hung up on it. So you have the energy, 15,000 joules. You have the mass of Chuck Norris's foot, and you solve for the velocity. And so as you solve for that velocity, the key is you have the energy and you're working backwards. So there you go. See you guys all Monday.